In this video, we will continue to look at partial fractions. So this is partial fractions part 2. So I talked in the last video about what to do with repeated factors in the denominator. And I just want to emphasize, in this case, we have a repeated factor of x to the third and x minus 1 squared. So both of those will have to be repeated in the partial fractions. So what we'd have in this case is a over x plus b over x squared plus c over x to the third plus d over x minus 1 plus e over x minus 1 squared. And we won't go into solving that. I just wanted to emphasize the way that you set these up. Now we're going to look at what to do when you have an irreducible quadratic factor in the denominator. In this case, we've got x squared plus 2, which you cannot factor with real factors, so you cannot reduce that any further. So let's look at how we're going to set up the partial fraction decomposition of this problem. So setting it up, it's a little bit different here. I'm going to start out with the easier one here. The order doesn't matter with your a's and b's. So I'll start out with a over x plus 1 is equal to, now we have the irreducible quadratic factor. And this, oops, wasn't a plus, equals as a plus. The irreducible factor has to be written under bx plus c. If you have an irreducible factor and it's quadratic, the numerator has to be written in this form. So now let's solve it. We solve it in very similar fashion. We need to get rid of the common denominator. So this will be equal to a times x squared plus 2 plus bx plus c times x plus 1. Now we pick our x's, and let's start off with getting rid of this one here. We'll solve for a by picking x to be -1. So if x is -1, then we have -1 squared, which is +1, and then a negative of that. So it's -1 minus 3 plus 1 is equal to a times -1 squared, which is 1 plus 2, and the x plus 1 makes this 0, so this entire term is gone. So over here we've got -4 plus 1 is -3 equals 3a, so a is equal to -1. Now we can use that in our next equation. Next one we're going to pick, we can't pick something, a real number here, to make the a go away because there is no factor. This is a parabola that shifted up 2 points and never crosses the x-axis, so there is no real 0 there. So we're going to pick another one. We'll pick a simple one. We're going to say that if x is equal to 0, and that works really nicely on the left-hand side because we have 0 plus 0 plus 1. So on the left-hand side we get 1. On the right-hand side we already know that a is -1, so we have -1 times 0 plus 2, which is 2, plus b times 0, which is 0, so we're left with just c there, times 0 plus 1, which is 1, so we have 1c. So this very nicely works out, and we add 2 to both sides, so we get c is equal to 3. So now we solve for 2 of them. We just need to solve for b. We know our a and our b, so we can write this out one more time, and let's just choose another simple one. Let's let x equal to 1. So if x is 1, we have negative 1 squared, which is negative 1, plus 3 plus 1 is equal to negative 1 for our a, times 1 squared is 1 plus 2 is 3, plus b times 1, bx is, b times 1 is b, and this is in parentheses, so b plus 3 times 1 plus 1 is 2. Simplifying our equation, we have on the left-hand side, we have 3. On the right hand, we get negative 3 plus distributive property here gives us 2b plus 6. 2b plus 6. Adding 6 and subtracting 6, we get 0 equals 2b, so our b is equal to 0. So I'm going to clear all this out and write out the final answer. So we know that a is equal to negative 1, b is equal to 0, and c is equal to 3. So our final answer, the partial fraction, is negative 1 over x plus 1 plus 0 times x is 0 plus 3 over x squared plus 2. And that is the partial decomposition of that. We're going to look at one more problem, sort of throwing it all together. We're just going to write out the factors of it, the decomposition. We're not going to solve for x in this case, or the a, b, and c. If we have a fraction with repeated irreducible quadratic factor, how do we set this one up? So this one's kind of complicated when you set it up. So let's start out. It's going to be pretty long, so I'm going to write it down here. Let's set out with our a over the first one over x plus b over x plus 2. The next one is irreducible, so that's going to be cx plus d. We just keep moving down the alphabet here, over x squared plus 2. And now we have, not only is it irreducible, but it's repeated. So what we have to do on this one, the next letter would be ex plus f over x squared plus 1, a, b, c, d, e, f, gx plus h over x squared plus 1 squared. I said it was getting long. Plus, so to continue down here, we are now ix plus j over x squared plus 1 cubed. So we're not going to worry about solving that, but just looking at how you set each one of these up. This first one and the second one are linear, and so they will just be under the single variable a and b. As soon as you get into the quadratic, then you need the cx plus d, and when you get into the repeated, you must have it one time for each of the exponents there. So there's the 1, 2, and 3. And now, just for fun, I want to ride my pi cycle. See you in class.